Chapter 1. Start here. How to use this Commute guide. Key points, exam facts, copyright-safe original narration, how to listen actively. This is your GH-600 Commute study guide for the GitHub Certified Agentic AI Developer Beta exam. It is built from the official Microsoft Learn certification page, the official GH-600 study guide, the 3 linked Microsoft Learn modules, and the GitHub documentation linked from the study guide. Important copyright note. This video does not contain ripped YouTube audio, copied Microsoft lecture audio, or third-party video. It is original narration and study structure based on official sources. Use the source links in the description for the canonical material. Here is the one-sentence mental model for the exam. Agents are contributors, and GitHub is the system of record and control plane. If you remember nothing else, remember that. The exam is not asking whether AI agents are cool. It is asking whether you can deploy, supervise, evaluate, and govern agents inside production software delivery. During this commute, do not try to memorize every product name. Listen for patterns. What should an agent be allowed to do? Where should the work be recorded? What evidence proves success? Which action needs human judgment? Which tool should be scoped or blocked? If a scenario sounds risky, your answer should usually involve branch scope, pull requests, checks, rule sets, code owners, logs, scans, artifacts, and the smallest human approval that actually reduces risk. The exam is 120 minutes. The official study guide says the assessed domains are architecture and SDLC, tool use and environment interaction, memory and state, evaluation and tuning, multi-agent coordination, and guardrails and accountability. The highest weighted domain is tool use and environment interaction. The rest are close enough that you should not ignore any of them. Use this video in 3 passes. First pass, just listen. Second pass, answer the scenario drills out loud. Third pass, pause on every wrong answer and explain the control you missed. Chapter 2. Exam map and default answer strategy. Key points, 6 domains, GitHub as control plane, default answer pattern. Let us map the exam. Domain 1 is prepare agent architecture and SDLC processes. This is 15 to 20%. It asks whether you can place agents into software delivery safely, define boundaries, make plans inspectable, and configure controls. Domain 2 is implement tool use and environment interaction. This is 20 to 25%. This is the largest slice. It covers tools, MCP servers, registries, allow lists, execution context, repository scope, branch scope, CI invocation, error handling, retries, rollback, escalation, and accountability. Domain 3 is manage memory, state, and execution. This is 10 to 15%. It asks how agents remember useful facts without carrying stale or conflicting context. Domain 4 is perform evaluation, error analysis, and tuning. This is 15 to 20%. This asks how you define success, collect signals, classify failures, and tune instructions, workflows, memory, and tools. Domain 5 is orchestrate multi-agent coordination. This is 15 to 20%. It covers parallel execution, isolation, conflict detection, handoffs, post-hoc analysis, recovery, and agent lifecycle. Domain 6 is implement guardrails and accountability. This is 10 to 15%. It covers autonomy levels, least privilege, human in the loop, compliance-sensitive actions, and auditability. Now the default answer strategy. If you are stuck, choose the answer that keeps GitHub as the source of truth, produces inspectable artifacts, scopes tools and permissions to least privilege, Separates planning from execution when risk is real. Uses branch, pull request, rule set, check. Code owners and environment controls. Adds human in the loop only where risk justifies it. Preserves logs and state, and uses evaluation signals instead of trust. The wrong answers usually fall into a few buckets. The first bad bucket is blind autonomy. Let the agent push, merge, deploy, delete, or change policy without controls. The second bad bucket is blanket shutdown. Block all agent behavior even when a scoped tool and review gate would be enough. The third bad bucket is hidden work. Summaries without artifacts, local changes without a branch, decisions not recorded anywhere, and work that cannot be audited. The fourth bad bucket is tool sprawl. Give every agent every MCP server and hope the model behaves. The fifth bad bucket is stale context. Persist old assumptions and use them forever. The passing instinct is not paranoia. It is controlled velocity. Move fast where risk is low. Add review and guardrails where the action is broad, irreversible, privileged, production-facing, compliance-sensitive, or security-sensitive. Chapter 3. Domain 1. Agent Architecture and SDLC Processes. Key points. Agents in SDLC, plans and success criteria, observability and controls. Domain 1 starts with integrating agents into the software development lifecycle. Think planning, implementation, validation, review, and deployment. The agent should have a defined job at a defined stage. It should not be a vague magic worker sitting above the process. A good agent task has 5 parts. First, inputs. That can be an issue, requirement, repository, branch, logs, test failure, or design. Second, scope. Which repository, branch, files, workflow, tools, and environment are in bounds. Third, outputs. A pull request, a plan, a report, a test artifact, a log, or a decision record. Fourth, success criteria. Which tests, scans, review rules, behavior, or quality bar proves completion. Fifth, failure path. Retry, rollback, escalate, or stop. The exam may ask about anti-patterns. Common anti-patterns are unrestricted autonomy, ambiguous prompts, no success criteria, hidden state, unreviewable outputs, stale memory, tool sprawl, agents that skip the pull request process, and agents that act before a plan is checked. Planning, reasoning, and action are separate ideas. Planning is the structured outline of what will happen. Reasoning is the internal or external analysis that leads to choices. Action is when the agent uses tools, changes code, opens pull requests, runs workflows, calls APIs, or touches data. For low-risk, read-only work, a lightweight plan may be enough. For risky work, planning should be explicit, structured, and validated before execution. The phrase inspectable artifact matters. A plan in a pull request body is inspectable. A checklist in an issue is inspectable. A workflow artifact is inspectable. A commit with logs and links is inspectable. A final chatbot message saying "done" is not enough. Now connect this to GitHub controls. Pull request templates force structured information. Code owners route sensitive areas to the right reviewers. Rule sets and branch protection enforce required checks and reviews. Environments can require approval before deployment. GitHub Actions produce repeatable validation and logs. Issues and pull requests preserve the work history. For observability, the agent should leave evidence in normal development tooling. You should be able to answer who triggered the agent, what it planned, what it changed, what tests ran, what scans found, what reviewers said, and what happened after failure. A key test phrase is human intervention without slowing delivery. That does not mean humans approve every tiny thing. It means humans approve the actions where judgment matters. A read-only code search does not need the same gate as production data deletion. Chapter 4. Domain 2, Tools, MCP, and Execution Environments. Key points: tool selection, MCP servers, CIN branch scope. Domain 2 is the biggest domain. Treat it as your scoring opportunity. Agents act through tools. A tool can read files, search code, edit files, run tests, call the GitHub API, open pull requests, access an MCP server, query documentation, or interact with CI. The first question is not, how many tools can I give the agent? The first question is, which tools are required for this task? The principle is least privilege. Give the agent the minimum tool access needed to finish the task for the minimum scope in the right environment with logs. If the agent only needs to inspect code, read and search tools are enough. If it needs to produce a plan, edit access may be limited to a markdown plan file. If it needs to modify code, branch-based edit access and pull request creation might be appropriate. If it needs deployment, the environment gate becomes important. MCP, the Model Context Protocol, extends agent capability through external tool servers. In exam language, MCP servers are powerful because they can connect the agent to APIs, databases, documentation, internal services, or specialized tools. That power is exactly why they need governance. A safe MCP setup asks 4 questions. 1. Why does this agent need this server? 2. Which operations are allowed? 3. How is the server registered and listed? 4. How is usage logged or reviewed? The wrong answer is to connect every MCP server because the agent might need it. That is tool sprawl. The study guide mentions GitHub Remote MCP Server, MCP registries, and MCP allow lists. Translate that into a scenario answer, use approved sources of tools, restrict what can be called, and prevent unapproved servers from silently expanding the agent's authority. Execution context matters. An agent running in a developer workstation has different risk than an agent running in CI. An agent scoped to a single repository is different from an agent with organization-wide access. An agent working on a feature branch is different from one touching the default branch. A workflow triggered by a pull request is different from a deployment workflow that can touch production. Agents can be invoked in CI workflows. That can be useful for repetitive tasks like generating reports, updating docs, triaging failures, or producing artifacts. But the workflow should define inputs, outputs, secrets boundaries, permissions, and expected artifacts. The agent should not be a hidden black box inside CI. Branch-based scope is one of the most exam-friendly controls. The agent works on a dedicated branch, creates or updates a pull request, and is subject to the same rules as other contributors. The agent does not get a free pass to merge or bypass the default branch protection. Now, error handling. Not all failures deserve the same response. A transient network failure can be retried. A deterministic test failure needs debugging. A permission failure means the environment or access is wrong. A risky partial deployment may need rollback. A compliance-sensitive ambiguity may require escalation. The exam will reward matching the recovery pattern to the failure mode. Traceability closes the loop. The agent action should be linked to an issue, branch, commit, pull request, workflow run, log, artifact, or audit event. If the organization cannot reconstruct what happened, the control plane failed. Chapter 5. Domain 3, Memory, state, and execution continuity. Key points: short-term memory, long-term memory, state artifacts, and drift. Memory is useful, but memory is also how agents become confidently wrong. Short-term memory is the task context inside the current run. It includes the issue, plan, files inspected, decisions made, errors found, and next step. It should be relevant to the current task. Long-term memory is durable knowledge that may help future tasks. Examples are repository conventions, build commands, architectural decisions, coding style, or user preferences. Long-term memory should be curated, scoped, and pruned. Do not store everything. Do not store secrets. Do not store facts that are not stable. External memory is the system of record information outside the model. GitHub issues, pull requests, commit history, logs, workflow artifacts, documentation, tickets, and decision records are external memory. For this exam, external memory is often safer than hidden model memory because it is inspectable and auditable. The official GitHub Copilot memory docs distinguish repository-level facts from user-level preferences. Repository facts are about a repository, such as conventions, build commands, architecture, and project rules. User-level preferences are personal workflow preferences. Repository facts can be useful to everyone working in that repository. User preferences should not become global rules for other people. Stale context is a major risk. Imagine memory says the repo uses jest, but the repo migrated to vdist. If the agent trusts stale memory, it runs the wrong commands and tunes the wrong workflow. A good system validates memory against current repository evidence, citations, or live files before using it. The docs also note expiration behavior for unused Copilot memory entries, which reinforces the broader point: memory should not last forever by default. State is different from memory. State captures where the task is. What phase are we in? What has already run? What failed? What branch exists? Which files changed? Which decisions were approved? What remains? Durable state prevents repeated work and prevents drift. Context drift happens when an extended agent run slowly diverges from the original task, current facts, or approved decisions. You prevent drift by writing down decisions, checking the plan against current state, validating assumptions, and forcing important updates into artifacts that humans and later agents can inspect. Continuity across tools and environments is another exam target. If one tool has one version of state and another tool has a conflicting version, the agent can make contradictory moves. Good workflows share state through clear artifacts, issue comments, pull request descriptions, workflow outputs, generated reports, and handoff notes. The exam pattern is simple. Persist what helps resume and audit the work. Prune what is stale. Scope memory to the repository, user, task, and risk. Never let memory override current source of truth evidence. Chapter 6. Domain 4, Evaluation, Failure Analysis, and Tuning. Key points: success signals, root causes, tuning based on evidence. Evaluation starts before the agent runs. If you did not define success, you cannot evaluate output cleanly. A strong success criterion is specific. Create a pull request that implements this behavior. All existing tests pass. New tests cover this edge case. Code scanning introduces no new high or critical findings. Secret scanning finds no new secrets. The pull request includes rollback notes. The generated artifact is attached to the workflow run. That is evaluable. Evaluation signals can be quantitative or qualitative. Quantitative signals include test pass rate, build status, code coverage, code QL findings, dependency advisories, secret scanning results, workflow duration, number of files changed, and error counts. Qualitative signals include reviewer judgment, whether the implementation matches intent, whether conventions were followed, whether the plan was clear, and whether the change is maintainable. The exam may mention automated scanning tools. Think CodeQL, code scanning, secret scanning, dependency checks, malware advisories, security validations, and normal CI tests. These are not magic, but they provide evidence. When an agent fails, classify the root cause. A reasoning error means the agent understood the tools, but made a bad inference or design choice. Tool misuse means it picked the wrong tool, used a tool outside its purpose, or had too much tool access. Context issues include stale memory, missing constraints, conflicting instructions, or drift. Environment issues include permissions, missing dependencies, network restrictions, runner limitations, secret availability, or branch protection. Do not tune blindly. If the root cause was missing success criteria, add criteria. If the root cause was wrong tool choice, refine tool instructions or permissions. If the root cause was stale memory, change memory validation or pruning. If the root cause was environment configuration, fix the runner, permission, or workflow. If the root cause was reasoning, improve the task framing, examples, or validation checkpoints. The smallest effective change is usually best. Do not give the agent admin access because it hit one permission error. Do not add every MCP server because it lacked one data source. Do not persist more memory because it misunderstood the current task. Tune the failing layer. Logs, plans, traces, outputs, workflow artifacts, and pull request discussion are your evidence trail. A final answer saying, "I failed because of permissions," is not as strong as a workflow log showing a specific token scope failure. For the exam, practice saying this sentence. Evaluate with evidence. Classify the failure, then tune the right layer. That sentence answers a surprising number of scenario questions. Chapter 7. Domain 5. Multi-agent coordination. Key points: isolation, conflict detection, recovery, and lifecycle. Multi-agent workflows are not just many agents running at once. They're coordinated systems with roles, boundaries, handoffs, and recovery. A common orchestration pattern is planner, implementer, reviewer. The planner creates a scoped plan. One or more implementers work on bounded tasks. A reviewer checks outputs against criteria. Another pattern is specialist agents by domain, such as front-end, back-end, security, documentation, or test repair. Another pattern is parallel exploration, where agents investigate separate approaches and a human or orchestrator chooses one. Parallel execution needs isolation. Give agents separate branches, workspaces, file ownership, or task scopes. If two agents edit the same files without coordination, you get merge conflicts, duplicated work, and contradictory outputs. If two agents make architectural decisions independently, you get design drift. Handoffs matter. A good handoff records what was done, what was decided, what changed, what failed, what remains, and what assumptions were made. A bad handoff says, "done," and leaves the next agent guessing. Observability for multi-agent systems means you can reconstruct the behavior of each agent and the system as a whole. Logs, artifacts, decision records, pull request comments, workflow outputs, and branch histories should show the sequence of actions and the reason for handoffs. Degraded behavior can look like an agent stalled, an agent repeating work, two agents solving the same task, agents producing contradictory outputs, or one agent undoing another agent's change. The recovery pattern depends on severity. You might cancel one branch, Merge the better one. Ask for human resolution, roll back changes, or reassign tasks with clearer boundaries. Life cycle matters too. Adding an agent to an existing workflow should not break current work. Updating an agent prompt or tool set should be versioned or documented. Replacing an agent should preserve continuity. Retiring an agent should preserve auditability. You do not want future reviewers wondering why a key workflow step disappeared. The exam will likely reward answers that balance parallel speed with isolation and review. The wrong answer is a pile of agents with shared write access and no coordination. The right answer is clear ownership, isolated execution, inspectable artifacts, and conflict resolution. Chapter 8. Domain 6. Guardrails and Accountability. Key points: autonomy levels, human in the loop, secrets, and sensitive actions. Guardrails are not about stopping agents from being useful. Guardrails are about making agent autonomy safe enough to use. Start by classifying action risk. Low-risk actions include reading docs, summarizing issues, searching code, and generating a draft plan. Medium-risk actions include editing code on a branch, creating a pull request, or running tests. High-risk actions include merging, deployment, deleting data, changing security controls, modifying compliance-sensitive settings, or accessing sensitive secrets. Autonomy levels should match risk. Low-risk read-only actions can usually be autonomous. Medium-risk branch work can be autonomous if pull request review and checks gate merge. High-risk production or compliance-sensitive actions need explicit authorization or controlled paths. Least privilege applies to tools, tokens, repositories, branches, workflows, environments, and secrets. If an agent does not need a secret, do not expose it. If it needs a narrow secret for a task, provide only that secret through controlled configuration. Never paste secrets into prompts or markdown files. GitHub guardrails include branch protection, rule sets, code owners, required reviews, required status checks, environment approvals, workflow permissions, secret stores, audit logs, and code scanning. For Copilot Cloud Agent specifically, GitHub docs discuss built-in mitigations such as limiting who can trigger the agent, limiting branch push scope, requiring human review before merge, restricting workflow runs by default, security validation, internet restrictions, and traceable commits and logs. Prompt injection is a real concern. Issues and comments can contain hidden or malicious instructions. Defenses include input filtering, scoped permissions, review, and not giving the agent more authority than the task requires. Do not depend on the model simply deciding to ignore bad instructions. Accountability asks, who initiated the action? What did the agent do? What evidence was produced? Who reviewed it? And what controls approved it? If those questions cannot be answered, the workflow is not accountable. The exam likes right-sized controls. Requiring human approval for every read-only search is too slow and not meaningful. Letting an agent delete production data without approval is reckless. The best answer is usually in the middle. Preserve velocity by approving only actions where approval materially reduces risk. Chapter 9. Scenario Drill 1-18. Key points: practice questions, answer out loud, root cause the control. Now we drill scenario questions 1-18. Try to answer before I say the answer. I will pause briefly after each question. Question 1. An organization wants an agent to fix issues directly on main to maximize speed. What is the best first control? A. Let the agent push to main if tests pass. B. Scope the agent to a branch and require pull request review/checks before merge. C. Disable all autonomous actions. D. Give the agent admin access but monitor logs. Answer: B. Agents should not write straight to the protected default branch. The safe pattern is scoped branch work, pull requests, required checks, and review. Question 2. A team says, ask the agent to modernize our API. What is missing before safe execution? A. A more powerful model. B. Inputs, outputs, success criteria, scope, and approval path. C. A second agent. D. A longer context window. Answer: B. A vague task is not executable governance. The agent needs clear inputs, outputs, scope, constraints, success criteria, and the approval path. Question 3. Which artifact best supports traceability for an agent-generated change? A. A Slack message saying the agent finished. B. A branch, pull request, commits, workflow logs, and review record. C. A local terminal screenshot. D. The agent's final natural language summary only. Answer: B. Traceability lives in the normal software workflow. Branches, commits, pull requests, checks, logs, and review history make the work inspectable. Question 4. When should an agent plan be separated from execution? A. Only for simple read-only tasks. B. When the action is risky, irreversible, broad, or requires review. C. Never, because it slows delivery. D. Only when more than 3 agents are involved. Answer: B. Risky or broad work needs a plan before tool action. The plan lets a human or policy check scope, impact, and rollback before execution. Question 5. What is the best way to add an MCP server to an agent workflow? A. Add every available server so the agent can choose. B. Add the required server, scope permissions, and use allow list/registry controls. C. Give the server full repository and network access. D. Add the server only after a failure occurs. Answer: B. MCP adds capability and attack surface. Add only what is needed, scope permissions, use registries or allow lists, and audit usage. Question 6. An agent repeatedly calls the wrong tool even though the task is clear. What tuning action fits best? A. Increase autonomy. B. Refine tool instructions and restrict or reorder tool access. C. Add long-term memory. D. Remove all logs. Answer: B. If the agent chooses the wrong tool, fix the tool instructions and access. More memory or autonomy will usually make the mistake faster, not safer. Question 7. A multi-agent run creates overlapping changes to the same files. What should you fix first? A. Give both agents write access to the same branch. B. Add isolation and ownership boundaries, then resolve conflicts through review/handoff. C. Delete both agents. D. Skip pull request review to avoid merge conflicts. Answer: B. Parallel agents need isolation and ownership boundaries. Same files, same branch, and unclear handoffs create avoidable conflicts. Question 8. Which is a good qualitative evaluation signal? A. Reviewer assessment that the pull request satisfies intent and follows project conventions. B. Number of tokens consumed. C. Model name. D. Whether the agent used natural language. Answer: A. A reviewer can judge whether the work satisfies intent and conventions. That is qualitative evidence. Question 9. Which is a good quantitative evaluation signal? A. The agent sounded confident. B. Tests passed, code scanning found 0 new high-severity findings, and workflow duration stayed within budget. C. The pull request title was short. D. The agent used many tools. Answer: B. Tests, scans, security findings, and workflow duration are measurable signals. Confidence is not a metric. Question 10. An agent needs credentials to deploy. What is the safest general pattern? A. Put secrets in prompt instructions. B. Store secrets in controlled secrets/variables and expose only what the task needs. C. Commit credentials to the repo temporarily. D. Give the agent access to all organization secrets. Answer: B. Secrets belong in controlled secret stores and variables. Never paste credentials into prompts or repositories. Question 11. A repository-level memory says the project uses Jest, but the repo migrated to Vitist. What risk does this represent? A. Tool sprawl. B. Stale context. C. Too much autonomy. D. Bad pull request template. Answer: B. A memory that no longer matches the repo is stale context. Stale context causes wrong tools and wrong assumptions. Question 12. What should durable agent state capture? A. Every token produced by the model. B. Task progress, decisions, artifacts, and enough context to resume without drifting. C. Only the final answer. D. User preferences from unrelated repositories. Answer: B. Durable state should support safe resume, capture progress, decisions, artifacts, and enough current context to avoid repeating or drifting. Question 13. A failed agent run includes correct reasoning, but a permissions error when accessing a tool. How should you classify the root cause? A. Reasoning error. B. Environment or permission issue. C. Memory pruning issue. D. Multi-agent conflict. Answer: B. The reasoning was not the failure. The tool could not be accessed because of environment or permission constraints. Question 14. A failed run uses an MCP server that was never needed for the task. What root cause is most likely? A. Tool misuse or overbroad tool access. B. Branch protection. C. Lack of human review. D. Insufficient pull request title length. Answer: A. Using an unnecessary tool is a tool selection and access problem. Reduce the tool surface and clarify when the tool is allowed. Question 15. What should happen to agent-created pull requests before merge? A. Automatic merge by the agent if it passes tests. B. Human review and required checks according to repository rules. C. Merge by the user who requested it without review. D. Delete workflow logs to reduce noise. Answer: B. Agent code still needs human review and required checks. Passing tests alone is not authority to merge. Question 16. Which control protects agent/MCP configuration files? A. Code owners plus rules requiring code owner review. B. A longer README. C. More agents reviewing each other. D. Disabling all tests. Answer: A. Code owners and rule sets protect high-risk configuration files by requiring the right reviewers. Question 17. What is the best way to preserve velocity while adding human in the loop? A. Require manual approval for every read-only operation. B. Require approval only for actions with meaningful operational, security, compliance, or irreversible risk. C. Remove all approvals. D. Ask a human after the agent has merged. Answer. B. Human reviews should be right-sized. Approve meaningful risk, not every harmless read action. Question 18. Which GitHub concept most directly makes agent work auditable? A. Private browser tabs. B. Commits, pull requests, logs, checks, audit events, and artifacts. C. The model's temperature. D. The number of custom agents. Answer. B. Auditability comes from recorded system artifacts, commits, pull requests, logs, checks, artifacts, and audit events. Chapter 10. Scenario Drill 19 to 36. Key points. Practice questions, answer out loud, root cause the control. Now we drill scenario questions 19 through 36. Try to answer before I say the answer. I will pause briefly after each question. Question 19. A team wants to run agents in parallel. What is the safest design? A. Shared branch, shared write permissions, no handoff docs. B. Isolated branches/scopes, clear ownership, handoff artifacts, conflict detection. C. One agent has admin rights over all others. D. Parallel agents should never be used. Answer. B. Parallel work is safe when each agent has clear scope, isolated branches, and handoff artifacts. Question 20. Which memory should be shared broadly? A. User-specific coding preference across all users. B. Repository-level convention relevant to the repo and validated against citations. C. A stale failed experiment from another repo. D. A secret copied from a prompt. Answer. B. Repository-level facts can be shared for that repository when validated. User-specific preferences should not become global rules for everyone. Question 21. An agent has a correct plan but starts acting before approval. Which boundary failed? A. Planning versus execution. B. Long-term memory. C. Quantitative evaluation. D. Repository visibility. Answer. A. The boundary between plan and execution failed. The agent acted before the plan was checked or approved. Question 22. What does a strong agent task success criterion look like? A. Make it better. B. Create a pull request that adds X, passes tests Y/C, includes rollback notes, and introduces no new high/critical security findings. C. Try your best. D. Use the fastest tool. Answer. B. A strong criterion names the expected output, validation checks, security bar, and rollback expectations. Question 23. What should an agent do after a transient CI failure? A. Retry if the workflow supports safe retry and the failure is transient. B. Immediately rewrite unrelated code. C. Merge anyway. D. Delete the CI workflow. Answer. A. Transient failures can be retried safely when the workflow supports it. Random rewrites are not recovery. Question 24. What should an agent do after a destructive migration failure? A. Continue retrying indefinitely. B. roll back or escalate according to the defined recovery path. C. Hide the logs. D. Add another MCP server. Answer. B. Destructive failures call for rollback or escalation. Infinite retry is how small incidents become big incidents. Question 25. Which statement about GitHub Copilot memory is accurate from the docs? A. It stores only global facts for all users. B. It can store repository-level facts and, for supported plans, user-level preferences. C. It never expires stored information. D. It should store secrets to speed future work. Answer. B. Copilot memory can store repository-level facts and user-level preferences on supported plans. It should never store secrets. Question 26. What is a good reason to retire an agent? A. The agent is unused or superseded, and the workflow can preserve auditability and continuity without it. B. The agent produced logs. C. The agent has least privilege tools. D. The agent creates pull requests. Answer. A. Retire agents when they are superseded or unused, while preserving auditability and workflow continuity. Question 27. Which is an anti-pattern? A. Explicit success criteria. B. Agent actions hidden outside the normal development workflow. C. Pull request review. D. Tool allow lists. Answer. B. Hidden agent actions outside the normal workflow are an anti-pattern. The exam loves inspectable artifacts. Question 28. A custom agent is specialized for implementation planning. Which tools should it likely have? A. Read/search/edit as needed, scoped to planning artifacts. B. Full production deploy access. C. Organization billing access. D. All MCP servers. Answer. A. A planning agent needs read, search, and maybe edit for plan files. It does not need deployment or billing power. Question 29. A branch protection rule blocks an agent commit due to metadata restrictions. What should you do? A. Disable all rules permanently. B. Adapt rule sets intentionally while preserving required controls. C. Give the agent bypass admin rights. D. Stop using pull requests. Answer. B. Rule sets can be adapted intentionally, but bypassing controls is the wrong instinct. Question 30. Why is GitHub Actions workflow approval important for agent-created pull requests? A. It makes the pull request title longer. B. It prevents unreviewed agent changes from automatically running workflows when policy requires approval. C. It disables all tests. D. It replaces human review. Answer. B. Workflow approval prevents unreviewed agent changes from kicking off risky automation when policy requires review. Question 31. What is the correct response to prompt injection risk in issues or comments? A. Trust comments from anyone. B. Apply input filtering, scoped permissions, review, and guardrails. C. Give the agent a bigger prompt. D. Disable logging. Answer. B. Prompt injection needs defense in depth, input filtering, scoped permissions, review, and guardrails. Question 32. What is the best first step when an agent's output is bad, but all tools executed correctly? A. Classify whether the miss came from instructions, success criteria, memory/context, or reasoning, then tune that layer. B. Add every MCP server. C. Remove pull request review. D. Store the bad output in long-term memory. Answer A. When tools ran correctly but output is bad, diagnose instructions, criteria, memory, context, or reasoning before tuning. Question 33. What should multi-agent post-hoc analysis include? A. Key decisions, handoffs, outcomes, logs/artifacts, conflicts, and recovery actions. B. Only the final merged commit. C. Only model names. D. Only total token cost. Answer A. Post-hoc analysis needs the full story: decisions, handoffs, outcomes, conflicts, artifacts, and recovery actions. Question 34. Which action is most likely to require explicit human authorization? A. Reading repository docs. B. Summarizing a pull request. C. Deleting production data or changing compliance-sensitive controls. D. Searching code. Answer C. Deleting production data or changing compliance-sensitive controls needs explicit human authorization. Question 35. A custom agent repository should be created from GitHub's template and named what for organization-level setup? A. .GitHub private B. Agent public C. Copilot main D. MCP all tools. Answer A. The organization-level custom agent repository pattern uses .GitHub private. Chapter 11. Hands-on lab walkthrough for the Commute. Key points: pull request template, code owners, rule sets, MCP allow list, failure report. This chapter turns the exam into muscle memory. You do not need to click through this while driving. Just picture the lab and explain each control. Lab 1. Create an agent-ready issue. The issue should not say, fix the app. It should say, implement a specific behavior in this repository on a dedicated branch with tests, no new high or critical security findings, and a pull request that includes risk notes and rollback notes. The issue is the task contract. Lab 2. Create a pull request template for agent work. The template asks for the plan, scope, files changed, tests run, scans run, risk level, rollback path, and human approvals required. Why does this matter? Because it turns agent work into reviewable evidence instead of a vague result. Lab 3. Protect sensitive paths with code owners. Imagine files like custom agent definitions, MCP configuration, workflow files, security policies, deployment scripts, and environment configuration. A code owner review requirement means the agent cannot quietly change the rules that control the agent. Lab 4. Add rule sets or branch protection. Require pull requests. Require status checks. Require review. Block direct pushes to the default branch. If a scenario asks how to let an agent move fast without losing control, this is the answer pattern: branch fast, review before merge. Lab 5. Configure a workflow that produces artifacts. The agent can run tests, generate a report, or attach logs. The artifact gives reviewers something concrete to inspect. A workflow artifact can also help another agent resume work without repeating everything. Lab 6. Design a custom agent profile. Give the agent a name, role, tools, and constraints. A planning agent may need read and search tools and permission to write a markdown plan. A coding agent may need edit and test tools scoped to a branch. A deployment agent needs much stronger environment gates. Do not give every agent the same tool belt. Lab 7. Sketch an MCP list. List each MCP server and the reason it is allowed. If you cannot explain why a server is needed, it should not be there. For each server, name allowed operations, blocked operations, and audit expectations. Remember, MCP is not just convenience. It is capability, and capability needs boundaries. Lab 8. Write a failure report. Start with the task, then the plan, then what happened, then evidence, logs, traces, tool calls, workflow output, pull request comments, and artifacts. Then classify the root cause, reasoning, tool misuse, context issue, environment issue, permission issue, or coordination issue. Then name the tuning action. This exact structure maps to the exam. Lab 9. Design a multi-agent workflow. Agent 1 plans. Agent 2 implements the backend. Agent 3 implements the front end. Agent 4 reviews security. Each agent has a branch or clearly isolated files. Handoffs are written into the pull request or issue. Conflicts are resolved by review, not by letting agents override each other. Lab 10. Define autonomy levels. Level 0 is read-only suggestion. Level 1 is draft plan. Level 2 is branch edits and pull request creation. Level 3 is workflow execution with approvals. Level 4 is deployment with environment gates. Level 5 is irreversible or compliance-sensitive action, which should require explicit human authorization. The names do not matter. The risk logic does. If you can mentally build those 10 labs, you understand the exam better than someone who watched 5 generic AI videos. GH-600 is about operationalizing agents in the software delivery system. The tool names matter, but the control pattern matters more. Chapter 12. Final cram and test day checklist. Key points. Answer pattern. Do not overthink. Ready criteria. Final cram. If you are stuck, ask, where is the source of truth? The exam answer usually keeps work in GitHub. Issues define tasks. Branches contain changes. Pull requests expose review. Checks validate. Rule sets enforce policy. Code owners routes ownership. Logs and artifacts preserve evidence. Ask, what is the risk of the action? Low-risk read actions can move quickly. Code changes need branch and pull request controls. Deployments and irreversible changes need stronger approval. Secrets and compliance controls need strict scoping. Ask, what artifact proves the work? A plan, branch, pull request, commit, workflow log, scan result, artifact, review, or audit event is proof. A confident final message is not proof. Ask, what failed? Reasoning, tool misuse, context drift, memory staleness, environment, permission, or coordination. Tune the failing layer, not everything. Ask, does memory help or hurt here? Use task-relevant memory. Validate repository facts. Prune stale entries. Keep secrets out. Use external system of record artifacts where possible. Ask, do agents overlap? Parallel agents need isolation, ownership, handoff notes, and conflict detection. More agents without coordination is not maturity. Before the exam, you should be able to explain these without notes. 1. Why agents should produce inspectable artifacts inside GitHub. 2. How branch, pull request, rule set, code owners, and checks govern autonomous work. 3. How MCP tools are scoped and listed. 4. How memory becomes stale and how to prevent it. 5. How to classify agent failures. 6. How to resolve multi-agent conflicts. 7. Which actions require human in the loop. The exam is trying to measure whether you can make agentic software development safe, fast, and auditable. Do not answer like a model fan. Answer like the person responsible when the agent breaks production. That is the game. GitHub is the control plane. Agents are contributors. Evidence beats vibes. Least privilege beats blind trust. Right-sized approval beats both reckless autonomy and bureaucratic slowdown. End of Commute Guide. Rerun the scenario drill chapters until the answer pattern feels automatic.